Acid-base titration part 2. We already know acid-base titration is a technique we use to determine the concentration of an acid or base by comparing with a standard solution. A neutralization reaction is carried out, and when we observe color change, that is the end of the reaction. Let's see an example of titration of monoprotic acid and monohydroxy base. The standard equation is HA, and you can notice there is only one hydrogen ion, MOH. This is monohydroxy base. You can notice there is only one hydroxide ions, and product is salt and water. At the end point, number of moles of hydrogen ions from acid would be equal to number of moles of hydroxide ions from base. How to calculate number of moles? Remember, molarity is equal to number of moles per liter of solution. We can rearrange this equation: moles of solute equal to molarity times liter of solution. Acid-base titration, there is one standard solution and acid-base indicator. Standard solution is a solution whose molarity is known or given. Standard solution slowly added to the unknown solution. Neutralization reaction takes place, and when color change, it is equivalence point, reaction completed. Total number of moles of hydrogen ions donated by acid is equal to total number of moles of hydrogen ions accepted by base. At the end, total moles of hydrogen ions would be equal to total moles of hydroxide ions. End point. End point is the point where you observe the color change. If indicator is chosen correctly, the end point is very close to the equivalence point. Look at this graph. Phenolphthalein has been used as an indicator, and on y-axis you can see pH, and on x-axis you can see the volume of base. Let's solve some problems. The formula we use: molarity of acid and volume of acid multiplied together would be equal to molarity of base and volume of base multiplied together. You can notice where we see hydrogen ions, it means it's an acid. So acid molarity times volume of acid, molarity of base times volume of base. So there are three relations: 1, 2, 3, 4. If you have been given 3, the fourth one you can calculate. Let's solve the problem now. This equation works really good for monoprotic acid and monohydroxy base. Monoprotic acid, there is only one hydrogen ions. Monohydroxy base, there is only one hydroxide ions. Okay? In a titration of 40 ml of nitric acid, so this is volume of acid, 35 ml of 0.100 molarity of NaOH is added. So this is volume of base, this is molarity of base. What do we have to find? molarity of acid. Now we calculate. First of all, equation. HNO3, you see only one hydrogen ion, so one H in acid. Only one hydroxide ions in base, so one. And water and salts are the product. This equation we will be using to solve the problem. We have noticed these three have been given. This one we have to find. How? Plug in the values. These two are multiplied, divide by this number, and we got the molarity of acid 0.0875. That's our answer. Let's see another example. What is the concentration of a hydrochloric acid if 50 ml of a 0.250 mole of KOH is a base? So this is volume of base, this is molarity of base. Neutralize 20 ml of the HCl, hydrochloric acid. So this is volume of acid. What we don't know, molarity of acid. Okay, first let's set up the equation. Again, one hydroxy ions in base, one hydrogen ions in acid, monoprotic acid, water and salt. Three things have been given, fourth one we have to find. Plug in the value, multiply these two numbers, divide by 20, and then we got the answer 0.625 m. Okay, let's see another example. This time little bit different. Concentration of a sulfuric acid solution is 50 ml of a 0.25 BaOH2, barium hydroxide. So this is volume of base, this is molarity of base, 20 ml of, so this is volume of acid, but we don't know molarity of acid. Equation. Now notice there are two hydrogen ions here, two hydroxide ions here. So this is diprotic. Di means two. Dihydroxy base. This is not monoprotic. Still, we will use same equation. These three have been given. Fourth one we have to find. And we got our answer 0.625 m is the molarity of acid. But now we have to adjust. How many hydrogen ions were there? 2. So our answer is 0.625. Therefore, we divide by 2. When we divide by 2, what we get? 0.31 m is the molarity of H2SO4. There are other types of titration based on redox reaction. Still, idea is the same. In reaction, we notice, we observe color change, and we use the stoichiometric equalities like we use in this problem. Salts. What are salts? A salt is an ionic compound containing positive ions other than hydrogen ions and negative ions other than hydroxide ions. Hydrolysis is the opposite of neutralization. Literally means water splitting, a reaction between water and the ion of a dissolved salt. When a salt undergoes hydrolysis, it reacts with water to form an acid and a base. Hydrolysis predicts salt is acidic, basic, or neutral. So we predict in which solution occurs when salts react with water. Neutral, acid, base, basics. How we determine that? If a strong acid react with a strong base, we get neutral salt. If a strong acid and weak base, we get acidic salt. If we got weak acid and strong base, we get basic salt. Okay? One more thing before I let you go. Buffers. What are buffers? Buffers are solutions that resist changes in pH when limited amounts of acid or base are added. A buffer is a mixture of a weak acid and its conjugate base, or a weak base and its conjugate acid. In the previous lessons, when we had started the chapter acids and base, we had explained what are acids and conjugate base. The mixtures of ions and molecules resist changes in pH by reacting with any H plus ions, hydrogen ions, or OH negative ions or hydroxide ions added to the solution. That's all for the day. Thank you so much for your time. If you haven't subscribed our channel, please do so now. And please don't forget to click on bell icon so that you can receive the notification of new lessons. We wish you a nice day.